In this video, we are going to study homogeneity of regression slopes with dummy variables in Python using Jupyter Notebook. As you can see at the bottom of the screen, this is an educational video only and no professional advice is included within it. Okay, so let's go into the web browser where the Jupyter Notebook is located. So the first step within the video regarding the Jupyter Notebook is that we need to add a new cell below, and we do so by clicking on Insert Cell Below button. And the first step within the video regarding the code is we need to import the corresponding packages. Therefore, we comment this as step 1, which is packages. And for this, we're going to import statsModels.api as SM. We're importing that feature from statsModels for data downloading. Then we're going to import statsModels.formula.api as SMF. We're importing that feature from statsModels for multiple linear regression calculation and for homogeneity wall test. To run these code lines or this cell, we can either click run or press Shift Enter on the keyboard. Then we continue with step number 2, which is data. For data, we're going to create an object named house prices underscore object, which is equal to, and we'll be using SM feature from statsModels.datasets.get underscore our dataset, and we open parentheses. Following parameters, which are data name equals to, within quotations, house prices, comma, package equals to, and within quotations, AER, comma, cache equals to true. So what we're doing here is we're downloading house prices object from our package AER, and with cache equals to true means that once we download the data, we save it locally, so we don't need to go and download it again every time we run the code. Notice that this will download data and documentation within house prices object. Therefore, we create a new object named house prices with only the data. Therefore, equals to house prices underscore object, and we get its .data attribute. So let's go ahead and visualize part of this data frame, and we do so with the print function, and within it we have house prices object, the one that only includes the data, with .head method, open and close parentheses. So again, to run this code lines or this cell, in this case we're going to directly press Shift Enter on the keyboard, and we can see part of this data, specifically the first 5 rows and all the columns of data. So in this video, we're going to focus on the following columns. First, at price, lot size, and bedrooms. And the reason for this is that we're going to fit a multiple linear regression in which price is the dependent or explained variable, which is being explained by the independent or explanatory variables of lot size and bedrooms. And then for wall test, we are going to add air conditioning as the dummy variable. This dummy variable also is going to be multiplied by the independent or explanatory variables of lot size and bedrooms. Notice that this air conditioning has value of no's, and below we have also yes, and Python will automatically convert this dummy variable into a binary variable of zeros when it is a no and 1 when it is a yes. If you want to read the full documentation of this data, you can do so with the following command, which is print, and we have from the house prices underscore object, we get its .2 underscores doc 2 underscores attribute, and to run this code line we press Shift Enter on the keyboard, and we can see the full documentation of this data. So now we continue with step number 3, which is the model. For this, we're going to create an object named MLR, which is multiple linear regression, equals to, we'll be using SMF feature from statsModels.ols, which stands for ordinary least squares function, and within it we have the following parameters. Formula equals to, and within quotations, because it is a string, we have the following. Price as the dependent or explained variable, special character means being explained by the independent or explanatory variables of lot size, plus bedrooms, plus, and as mentioned previously for wall test, we are going to add air conditioning as the dummy variable, plus the products of lot size multiplied by air conditioning, plus bedrooms multiplied by air conditioning, comma, data equals to the house prices object we created above, and we fit this regression, open and close parentheses. And what we want to do is we want to print the results from this regression, and we do so with the print command, and from the MLR object we get its summary method, open and close parentheses. So to run these code lines or this cell, we press Shift Enter on the keyboard, and we can see the results from this OLS or ordinary least squares regression. And specifically, we want to focus on the coefficients here. So we have the coefficients, and specifically we want to focus on the ones related to the dummy variable. So we have air conditioning, and here we see within brackets t.yes. As mentioned previously, Python automatically converts that dummy variable into a binary variable with no's as zeros and ones as yes. Therefore, this is air conditioning when 1 or yes. And also for the products, lot size multiplied by air conditioning when it is yes or when it is equal to 1, and bedrooms multiplied by air conditioning when it is yes or equal to 1. Also relevant is the names here of the coefficients because we're going to be using them for wall tests, specifically having that t.yes within brackets. And also notice here that instead of having the multiplication symbol, the one we had here, when it's being printed in the results, now we have semicolons in these cases. So now we can continue with step number 4, which is homogeneity. And for this, we're going to do walled test. And for walled test, we're going to create an object named walled test, which is equal to, and from the MLR object, we get its walled underscore test function, and within parentheses, the following parameters. First of this, which is our underscore matrix, and this includes the null hypothesis for walled test. It's a joint null hypothesis within quotations, which is as follows. So we have air conditioning with t.yes, notice the capital T, equals to, and as mentioned, we're also adding the product. So we have lot size, semicolons, air conditioning with capital T.yes equals to, and then we have bedrooms, semicolons, air conditioning, capital T.yes, and all of them equal to 0. So as mentioned, we have as null hypothesis, it's a joint null hypothesis, that air conditioning and the product of air conditioning multiplied by lot size and air conditioning multiplied by bedrooms, all of them are equal to 0. Notice that we use the t.yes within brackets in all cases and the semicolons for the products the same as within the regression results. Comma, use underscore f equals to true, so this is going to perform an f test. So this is a walled f test with the joint null hypothesis that dummy variable and dummy variable products with independent variables coefficients are equal to 0. Notice that the dummy variable chosen, in this case air conditioning, and f test parameter with use f equals to true were only included as educational examples which can be modified according to your needs. So then at the following row, we are going to print the results for this walled test. So we do so with print walled test. And again, to run these code lines, we're going to directly press Shift Enter on the keyboard, and there we can see the results for walled test. We have the F statistic, number of degrees of freedom, and the F statistic p-value. This is the walled F test p-value with the joint null hypothesis that air conditioning and air conditioning products with lot size and bedrooms coefficients are equal to 0. If rejected linear regression intercept and or slopes are not homogeneous, or there are changes in intercept and or slopes when house prices are classified according to houses having air conditioning or not. If not rejected, linear regression intercept and or slopes are homogeneous, or there are no changes in intercept and or slopes when house prices are classified according to houses having air conditioning or not. Okay. So with this, we finished with the code file, so we can go ahead and save it. And with this, we also finish with this video. Thank you for watching.